All right, quick community updates. This is the current team. We have a lot of folks at Sandia, UHC at CA, but we also have a lot of partners at various other labs. This is going pretty well. Primary users, since it's not too important, I'll move on to the library updates, which is hopefully the part that you're most curious and excited about. So for Kokkos-Kernels, so like Damien mentioned it earlier, we have the same release cycle as Kokkos Core. So we've had 3 releases since May 25, the 4.7 in August. We missed our July by like a few days. At that point, we did a lot of cleanups because we were working toward the major release, which is when we allow ourselves to remove a bunch of stuff that's deprecated. So that was one of the big focus for us. In November, we had Kokkos 5. We removed a lot of these features. We moved up to new compilers, CMake, and there are also potential TPL requirements that change, and we're going to do some work to spell it out. We haven't really had a good policy around it. For example, OpenBlast, I guess we let you kind of use anything, even though we know that some of the older versions are buggy, and we have in our own code base some kind of like fixes to work around these issues, but we're going to start to spell out our requirements so that hopefully in the future we don't have to maintain these bug fixes for others, and also so that you have some guidance as to what we've seen works well on various platforms. And so for our 5.1, which will happen, I guess, early April, maybe even a little earlier than that in March, we have the release candidate branch up on Kokkos Core and Kokkos-Kernels. So this is a great time to check it out, to see what works and doesn't work, to let us know if you want a quick, bug fix here and there. There's still a little bit of time. Okay. So the new kernels, we do not have anything new in BLAS. We have a pretty complete implementation for the general matrix support, some batched kernels that we've added, so some symmetric rank update, some triangular solves for band format, and a lot of new feature in the specifically serial QR code for complex and rectangular type of matrix. So this complex and rectangular support will be expanded to not just the serial, but to the team vector and team and etc. So we're slowly working it up. So yeah, watch out for that. Once you understand it in serial, it's kind of okay to move it up. Okay, sparse matrices. So we have this new cell matrix. It's a sliced LPAC format. If you've been working with these things, it's basically helpful if you have pretty good regularity on your grid, but it doesn't have to be perfect. It still gives you some ability to have variability in the number of entries per row. It should provide better performance on GPU. So if you want to play with it, it's currently under experimental. We've also added a matrix vector product that supports this cell format because that's kind of the first building block that you need out of it. We are going to try to strengthen this, do more testing, and hopefully from your feedback we'll be able to move that out of experimental pretty soon, but let's see how that goes. We've recently had some improvement in our sort CRS matrix, so we now support shell and radix, parallel thread level, and bulk sort. So among these improvements, so the shell is new and the radix algorithms are performing up to 2x due to some loop fusion that we've done. So hopefully if you're using some matrix sortings, you'll see it as like a free speed up. If you're rolling your own, maybe it's time to give it another try, see how that goes. LPAC support, so more QR. So this one is, since it's in the LPAC namespace, it's something you can call from host. We're performing the GQRF, which is the general QR factorization, and in conjunction with that, we have the orthogonal or unitary matrix multiply from QR. if people require it, we can add the formation of the Q matrix itself. It's not been viewed as most critical so far, so you could multiply Q by the identity and you'd get Q out of it anyway, but let us know. And then for graph, so the sorting facilities that sort the CRS matrix are fairly similar to what we've done in terms of CRS graph. So again, some speed up over there. And we've done some work on recursive coordinate bisection, which is basically an algorithm that allow you to, given a set of coordinate and a graph, split your problem into further subdomains. So think of it as graph partitioning. And that's getting more and more robust. Okay, general library improvements. The build system has been cleaned a little bit. We've removed some duplicated target definitions. We are slowly moving toward enforcing find package as the primary mechanism to detect and enable the TPLs. We used to have kind of an older way of doing these things, and that was leading to various bugs for various customers and downstream application. So I think this will be more robust going forward. If you do notice issues with it, like we had at the beginning for our NVHPC support, please let us know, and we're going to be doing our best to strengthen that further. But so far, it's been an overall positive experience moving toward this pattern. Other improvement, we've made a bunch of stuff faster, like our parallel UT setup, which was definitely a performance bug, gained up to an order of magnitude performance. SPL UK, we used to have strong requirement, which I think was, let us look at how much free memory is on the GPU. We're going to grab all that just to be safe and attempt to perform our factorization. And now we are capping that a little bit more aggressively so that you can run all the stuff in parallel. Transpose operation performance has also been improved. Regarding vendor support, we added Apple Accelerate support for BLAS and LAPACK, and we're fixing some support for ARM-PL, and we are doing kind of a revival of our testing of ARM performance libraries, and specifically the conjunction of the ARM performance libraries with NVIDIA GPUs. Okay, some infrastructure improvements. So I think Christian and Damien hit these points already, but we've done various hackathons. We've worked a lot with AMD in Albuquerque. We've worked with Next Silicon ahead of the new backends. You might have met us at SC or HPC Asia. And we just had our developers meeting last week in Albuquerque. Okay, some CI/CD release and release update. So we have new CI builds, debug build, sanitizer build for CUDA. We also have a new CUDA 13 image. So the CI build itself is in progress, but with the image ready and everything testing on it, I think we should be able to push that further soon. And we're adding SQL testing as well. We have updated our warning checks. That might not be something that you see a lot, so I'll go quickly over it. Zenodo, as Damien mentioned, we're doing our DOI. We're working on GitHub integration. I did it initially with a manual process, and now I'm regretting my choice. So, but we're getting support from Zenodo to do that. We have modified a little bit our semantic versioning, and like we mentioned previously, we have this more regular cadence of 3 releases per year, and we're thinking about actually having a schedule for that. And all right, finishing almost on time. Here is what I'm looking at for new features. So we're going to look at Kokkos factorization for the LAPACK support. We're thinking about this Q factor formation. For the cell SPMV, we want to look at a more performant implementation using our native implementation, so not vendor backends. And we're looking at new ILUK variants. For mixed precision support, current implementation is under review. And so by this, I mean like we want to go through the library and just make sure that everything that we support is actually supported well in terms of accumulator types that are potentially different from other types in our API. And then we want to go through our dense and sparse linear algebra as well as our iterative solvers just to harden again this capabilities. And that's it. If you have any questions.
I think we can take a couple questions before we all break for coffee, if anybody has anything. If not,
For me or Damien or Christian.
Yeah.
Can you comment, I haven't been to it recently, what's been moved out of experimental?
So the question was, what's been moved out of experimental namespaces? What did we move? Did we move anything?
I think nothing, but we've heard. I mean, do you have some specific one? Offset view.
Yeah, I mean, like, okay, so the experimental namespace thing is something where, yeah, you have seen that stuff has been lingering a long time in these places. That is for multiple reasons. One is when we don't get feedback on features and we don't know whether they are successfully used and people are happy with it, right? If you tell us, you've been using offset view for a while and you're happy with it, we can certainly consider that. There is a couple other ones where we are unhappy with the actual implementation, like or API, like scatter view, for example. I have somewhere on my laptop a rework of that with improvements to how the API works, and I need to get that in before I'm happy to make that non-experimental. For many of these experimental things, it doesn't mean that it's not supported or that it's not, that you shouldn't use it, right? Or that we're, it's really just that we are not quite necessarily happy with it. If you look back, right, a lot of our non-experimental capabilities, right, are extremely stable, right? Like you can, in many cases, you can still compile code from like 10 years ago, right, directly against current Kokkos, and it will just work, right? And that's kind of the goal we have with that stuff.
So we are aware about partition space, but it's that we had many requests to promote. But if there are other things that we are not thinking of beside partition space and offset view, just reach out.
Oh, unique token is in experimental?
Yep. Oh. It's another one where some of us don't like the interface.
Along the lines of the previous questions, all the mixed and lower and half position, etc., is still all in experimental. Like we start using it.
Oh yeah, please start using it, but it's in experimental for good reasons.
Yeah, but again, right, it's something where we want feedback from actual users saying this fully works and we don't run into trouble, right? So something in experimental doesn't mean you shouldn't use it. It actually means, yes, we do want people to use it and get feedback that we are actually sure, right? It's just that you need to be aware that maybe there might be some tweaks to the interface we need to do based on feedback we get from real production usage, right?
So we, just one second, we try to work with you, even though we said experimental is lowest guarantee. When things have been around for a long time and we know of users, we go through the deprecation cycle to migrate to the newer thing.
Yes, it's everywhere, right? The old stuff is not used anywhere. You had another question? No?
I guess continuing with the half and mixed position, I was trying to find anything in the documentation and the examples and the tutorials. Maybe it's me not being familiar with it, but I couldn't find much about half T, except somewhere in the tests.
There is something, but it doesn't it's not at the level it should be. If you go under numerics, in the API numerics, it's going to be mentioned, but you're probably not going to be happy with it. It's in progress.
Yeah. I mean, in practice, right, it's just the half type, and then everything else should just work, right? That's the goal, right? Okay. Anything else? If not,
You're going to put the slides on the Kokkos core updates.
These ones?
We're gonna upload them to the SCAD system. We just finished the slide a few minutes before, so.
Okay, thanks. Then see you all back in a little bit and with all the user talks. Thank you.